Okay, Trig. We're in the second half of R7. We're in example 4, and we've only got, I think, 3 problems left. 4, 5, 6, but they all have like an A, B. Well, I guess 5 doesn't. But lots of steps are going on in these story problems here. And so this one is involving work rates. And I think you have a homework assignment that's like this. So it's going to be very, very similar to this process, okay? So this one starts with a mail order company, Derek can process 100 orders in 4 hours. Okay, so I'm going to kind of write that as a rate, like 100 orders per 4 hours, right? Like that would be like miles per hour or whatever, but this is orders per hour, right? So 100 orders per 4 hours. So 100 orders in 4 hours. We could reduce that if we wanted to and like be 25 over 1, but let's just wait a second. And let's do this. The next one says that Miguel can process 100 orders in 3 hours. So this is Derek and Miguel. 100. Whoa, there my pen's doing weird things again. 100 per 3 hours. Okay. How long would it take them to process 100 orders if they work together? So what we have going on here is we have 2 people working, and we are adding their efforts together to get a total effort, right? So the work done here plus the work done here gives me the total work together. Okay, and the way that this is set up is we have orders per hour and orders per hour, and then we're going to have orders per hour, right? So let's start with 100 over 4 is what we've got going on here. 100 over 3. I want to know how long it will take me to process 100 orders. So I want the work done over here to be 100, but I don't know how long that's going to take. Right, so I've got like X on the bottom. I want it to result into that, and I want to figure out what that X amount has to be, and that's the number of hours it's going to take. So all I have to do is look at this and find a common denominator with those 3, okay? So here I've got this plus this equals this, and I've got my denominators are 4, 3, and X. So I'm going to do 12X as my denominator, okay? Again, I get these numbers from just the way, the order of which it is in the example. 100 orders in 4 hours. That's 100 over 4, or 100 per 4, right? All right, so 12X is my bottom. I've got 100 on the top here for each one of these. And then I'm just going to compare, like, what do they need? What does this 4 need to be multiplied by to get 12? So I have to get 3 times X to get 12X, right? This guy, what does he need? He needs to be multiplied by 4X. And this one just needs multiplied by 12, okay? And now the nice thing is when I have my denominators all the same, I can cross those off and then just have the top left. So I've got 300X plus 400X equals 1,200. Okay, now if I add my x's together, I have 700x, and that gives you 1,200. And if I divide by 700, oh, that's going to give me like a decimal. I can cross those off there. 12 over 7, I don't know. I'll do it as a decimal, I guess. 12 divided by 7. That is 1.71 hours. Is how long it would take if both people work together. So that's how that works. Now, again, I could have reduced some of those things, whatever, but I just left it the way that it was. If I don't want to have to think about reducing, that's totally fine. 1.71 hours. Okay, now that answers part A. How long would it take them to process 100 orders together? And that makes sense, right? If it takes one individually 4 hours and one individually 3 hours together, they're gonna go pretty fast, right? How long would it take them to process 1,400 orders if they work together, right? Well, they're doing 100 orders in 1.71, right? This is equivalent to 100 orders. But I want 1,400 orders, which is 14 times more than what this is, right? This is 100. If I want 1,400, all I'm going to have to do is take this times 14, because that's 1,400 or 14 times more orders than what I had before. So I'm going to take that same decimal that I have in my calculator already, and I'm just going to take it times 14, and it says it's going to take 24 hours to process that many orders. Now, that's assuming, again, that you don't take like breaks or anything like that, whatever, right? This is aside from that, okay? Hopefully that made sense, okay? But this is going to be how you're going to set up those work problems. Something over, like, whatever divided by time, and you're adding efforts together to be a total, okay? All right, this one, we're going to do Pythagorean theorem on this one. Okay, so it says a window is in the shape of a rectangle with an adjacent right triangle. So they've drawn a picture of it over here. Okay, here's my right triangle at the top. And it says the length of one leg of the right triangle is 2 feet less than the length of the hypotenuse. So they have the hypotenuse is x, and then this length is x minus 2. The length of the other leg is 1 foot less than the length of this hypotenuse, okay? Find the lengths of the sides. Okay, I actually know what the answer is right now because I know my Pythagorean triples. Well, that's exciting. And you might be able to guess this also, but let's set this up, okay? So here's the relationship that I have for my sides, and I'm going to use the Pythagorean theorem, which says a squared plus b squared equals c squared, okay? It doesn't matter which one of these sides you call a and b, but c has to be this guy right here. So I'm going to put x in place of that guy. So this will be x squared, okay? Then this a, let's just call a the x minus 1. Sure. Oh, I've got weird things going on. Let's say b is x minus 2. Okay. And then all we're going to have to do is we're going to have to FOIL. Like the x minus 1 squared and the x minus 2 squared. What? Yeah. You want this off? Okay. All right, so we've got to FOIL the x minus 1 squared, which means x minus 1 times x minus 1. And if I do that off to the side, you can probably do this in your head, but I'll write it all out. X squared minus 1x minus another 1x plus 1. So he will end up being x squared minus 2x plus 1. That's what that ends up being, okay? Then I'm going to start on the x minus 2 squared, so x minus 2 times x minus 2. And that is x squared minus 2x minus another 2x plus 4. Or x squared minus 4x plus 4. And then I have equals x squared here. All right, let's put this left side together real quick before we start moving stuff around. And here we've got 2x squared minus 6x plus 5 equals x squared. I'm going to bump this x squared to the other side, which makes it really nice because now it's a simple trinomial, right? It goes back from being a 2x squared to just x squared. And then I have plus 5 equals 0. Okay, what can I multiply to get 5? But when I add them, give me negative 6 is negative 5 and positive 1. Okay. Oh, sorry, I didn't mean to put equal. Not positive 1. X minus 5, x minus 1 will give me those two. All right, so if I set those equal to 0, x will be equal to 5, and x will be equal to positive 1. All right, now here's the deal. If x is 5, 5 goes here, 5 is x, 5 is my hypotenuse, right? This guy will be 3, because 5 minus 2 is 3, and this guy will be 5, and that is 4, right? So I have a 3, 4, 5 right triangle, which was the one that I was thinking of in my head when I first did this problem. I'm like, oh, I know 3, 4, 5 is a special right triangle, and that does have the relationship of x minus 2, and x minus 1, okay? Now, well, I have two answers, though, because what if x is actually equal to 1? Like, what if the hypotenuse is 1? Well, we have kind of a problem here because 1 minus 2 is going to make this side a negative 1, and 1 minus 1 is going to make this side 0. So even though x came out as a positive number, this is not going to be a solution because when I plug him in, he's going to end up giving me negative numbers for my side length. So that's not going to work. It says find the lengths of the sides. The sides are 3, 4, 5. Yep, there is that, okay? So that was the Pythagorean theorem, little tricky thing, all right? Okay, last thing is talking about like projectile motion, okay? So you may have seen this equation before in like physics, but okay, so let me just break this down. So the position function, so this is like the position of, let's say I'm on a cliff, and I'm like dropping, like I'm kicking a ball off a cliff, right? So what's happening is it's doing this, it's going to go up in the air and it's going to come back down, which is kind of like a parabola, right? Like it's doing one of these, okay? Or maybe I'm just even kicking it from ground level. It wouldn't have to be standing on a cliff, right? Like I could be doing any of that. And what that's going to be is a downward parabola, which means it's a negative x squared, or a negative t squared in this case, okay? So that's where the parent function of this equation originates, okay? They say negative 1/2, and then g is either 32 feet per second or 9.8 meters per second. I know you've seen that before. 9.8 meters per second squared is the acceleration due to gravity, okay? So that is how that works. And we're going to plug one of those two numbers in for g, depending on whether my story problem is in feet or in meters, okay? So we'll figure that out here in just a second. But then we have t is my variable. T is time. We don't know what time is, so we're going to leave that as t squared. But then v naught is your initial velocity. They tell you that right here, initial velocity. So that means that as this ball is kicked off of this cliff here, the force or the speed at which I kick it off the cliff here is going to depend on or is going to tell me, how fast it's going to be before he hits the earth, okay? Another way of thinking of this is like, let's say I'm taking a rock and I'm dropping the rock off a cliff, right? Like if I take this rock and I just go whoop and I drop it off the cliff, versus if I throw it down, that is going to, like, the thrown down one is going to hit the ground faster than me if I just drop it off. So initial velocity does determine, a lot about your function and when it's going to hit the ground. And S is the position, okay? So like the height of the rock as it falls. And then S naught is the initial height that we're starting at. So if we're starting from ground level, that would be 0. If we're starting from 100 feet in the air, that would be 100, right? That's what your vertical position is what it says there. All right, so we're going to plug stuff in. Let's see what we've got. A model rocket is shot straight up from a launch pad 1 meters above ground, okay? It's starting at 1 meter above ground. That is the initial height, so that's going to be my S naught. I'm going to put that in here. I'm going to put that in as 1. And, okay, we're in meters, which means I'm going to use the 9.8 as the G part. Okay, now the only other piece of information I need is V naught, and that is the initial velocity, which is 24 meters per second. So write a model to express the height. Height, they always refer to height as S. I don't know why. I don't know why S. Like, why not H? I don't know. I haven't figured that out yet. Yeah, vertical position, that doesn't make any sense to me, S. So if you have any suggestions on that, let me know. All right, negative 1/2 times 9.8, because that's what we're plugging in for G, because we're in meters per second. T just stays as T squared, or as the variable T, plus V naught is going to be 24T plus 1. Okay, so if I want to fix that, the only thing I would fix is 1/2 of 9.8 is going to be 4.9. So this would be negative 4.9 if you want to change that. T squared plus 24T plus 1. Okay, now find the time at which the rocket is a height of 20 meters. Okay, round to 1 decimal place. So I'm not plugging 20 in for T. That would be really nice. I am plugging 20 in for S over here, and I'm solving for T. All right, so I'm going to do this down over here because I need some room. 20, ugh, my thing hates it again. 20 equals negative 4.9 T squared plus 24T plus 1. Okay. All right. Megan's going to yell at me. Megan or Remington. They're both probably going to yell at me. I'm going to move all this stuff to this side. You know why? Because I like the T squared to be positive. I don't know. All right. 4.9 T squared minus 24T. Right, if I move those over, this would be minus 1, so that would actually be plus 19 equals 0. All right, this is going to be really ugly. I'm not even going to try to do a complex trinomial there because we have decimals, and I doubt it's going to work, so let's just do the quadratic formula. Here we go. Negative, I'll write out the quadratic formula, negative b plus minus square root b squared minus 4ac. I got to get my calculator out. 2a. All right, here we go. Negative b will be positive 24 plus and minus the square root of, I think it's like 576 is what 24 squared is. Yeah, it is. I don't know how I know that one, but I don't know some of the other ones underneath of it. 4 times a, which is 4.9, times c is 19. Okay, I'll figure that out here in a second. 2 times 4.9. Okay. 4 times 4.9 times 19 is minus 372.4. Okay. And if I take if I figure that out in there, this is 24 plus minus the square root of 203.6 all over 9.8. Okay, the square root of 203.6. Oh gosh, I don't know why I cleared it out. 203.6 square root. This thing right here is 14.27, let's say. Okay. All right, now I have two answers. One of them is going to be 24 plus 14.27 divided by 9.8. And that answer is 3.9. And the other answer, 24 minus 14.27 divided by 9.8 is at 0.99, okay? And that answer is in seconds. So what this means is I have two places where it has a height of 20 meters because we're kicking it, and I don't know. Oh, the rocket. Okay, the rocket is starting at 1 meter, right? So here's ground level, right? Starting at 1 meter. I should move him over. Okay, whatever. Starting at 1 meter, right? And it's going up and then it's coming back down. Well, they want to know when it's hitting 20 meters. So let's say 20 meters is right here. It's going to hit on the way up and it's going to hit on the way down. And it's hitting on the way up at 0.99 seconds and it's hitting the way down at 3.9 seconds. Okay. So that is why we have two answers. We will have two answers on that. Not just one and we cancel out the other one. We will have two answers. So find the times at which the rocket is at a height of 40 meters. Okay, if I plug in 40 for this and I subtract 1, I would end up getting 39. I'm totally cheating on some of this, okay? So I'm just going to go back through my quadratic formula, and instead of erasing everything, I'm going to put a 39 in this spot. So I'll end up with 24 plus minus. This will stay 9.8 on the bottom, but I will have the square root of, let me fix these numbers. I know what's going to happen to this. Do you know what's going to happen to this? 4 times 4.9 times 39 is negative 764.4. Oh gosh. 64.4. And if I take 576 and I subtract that, I get negative 188.4. Okay? So, and this is going to end up being an imaginary number. So why do I get an imaginary answer, right? It says it will hit a height of 40 at an imaginary place, which means that it's not going to hit 40, right? 40 is like all the way up here, and it's never going to reach that height, okay? The maximum height is going to max out at some place, right? Below 40. I don't know what that is, but it will not hit 40 meters, okay? All right, so that's how that works out. You should, I think, have maybe one homework problem for each kind of type of problem. So go back through and try to get those figured out. Use your notes, and it should be pretty well similar examples. Just plop in the different numbers and see if you can do the algebra. Okay, there you go.